But it's a curiosity as to where we are, what we are. It's very much more exciting to discover we're on a ball, half of it sticking upside down. It's spinning around in space. There's a mysterious force which holds us on. It's going around a great big glob of gas that's burning fueled by a fire that's completely different than the fire, any fire we can make. Well, now we can make that fire, nuclear fire. No. But that's a much more exciting story to many people than the tales which other people used to make up who worried about the universe, that we were living on the back of a turtle or something like that. They were wonderful stories, but the truth is so much more remarkable. And so what's the pleasure in physics is that, to me, is that as it's revealed, the truth is so remarkable, so amazing. And I have this disease, and many other people who have studied far enough to begin to understand a little of how things work are fascinated by it. And this fascination drives them on to such an extent that they've been able to convince governments and so on to keep supporting them in this investigation that the race is making into its own environment.
Water, when unmanipulated, is to find its level, so whether you look at a cup of water, a bathtub, a swimming pool, a lake, or the ocean, it's flat. Of course, natural motion is not considered and doesn't equal a curve. We have 0 authentic pictures of the Earth, and they're all composites, and NASA even admits that they Photoshop Earth images.
It is Photoshopped, but it has to be.
On numerous occasions, NASA admits that we can't go beyond low Earth orbit, which is between 99 miles and 1,200 miles away. The interesting thing is that the moon is said to be 238,000 miles away, which is a difference of 236,800 miles. No matter if you're on the ground, on top of a building, a mountain, a hot air balloon, an airplane, or looking at high-altitude amateur balloon footage, the horizon never fails to rise right to your eyes. Whether you are looking at Toronto's skyline from Niagara-on-the-Lake, 31 miles away, Chicago's skyline from Union Pier, 43 miles away, or even Oahu from Kauai, which is up to 108 miles away from center to center, or 73 miles away from the closest points. You will not see any curvature where it's supposed to be. According to the Pythagorean theorem, which states that the curvature of the Earth is 8 inches per mile squared, Oahu should not be visible whatsoever, but you can see the whole thing. In 1887, Albert Michelson and Edward Morley conducted what's known as the Michelson-Morley experiment. This experiment was attempting to prove the speculated motion of the Earth around the Sun, and when it failed, Albert Einstein was forced to form the theory of relativity to overcome this problem. In fact, anytime mainstream science is faced with undesirable results, they create a workaround, which isn't real science at all. The Sun is claimed to be 93 million miles away, with a radius of over 400,000 miles, but can easily be proven to be much closer and smaller by tracing the crepuscular rays back to its origin in the sky. If the Sun were indeed 93 million miles away, it would simply be impossible to have angled sun rays, as they should all consistently come in straight. According to the globular theory, a lunar eclipse occurs when the Sun, Earth, and Moon are in a direct line, but it is on record that since about the 15th century, over 50 eclipses have occurred while both the Sun and Moon are visible above the horizon. F. H. Cook, The Terrestrial Plane. It's a common misconception that the shadow of the Earth causes moon phases. Even the pastors and priests of the science religion readily admit this fact. The interesting thing about moon phases is that they are always the exact same 8 phases repeated. But if we were circling around the Sun, these 8 phases would inevitably be reversed from the summer to winter seasons. I completely understand that the idea of a flattened stationary Earth seems ridiculous in many ways, but that's only because we are taught the false globe model from the very first time that we enter a school classroom. Not to mention the first time we are introduced to the concept of a flat Earth, it's depicted as a highly laughable world where ships, boats, and water would run off of the edge. So I do get it, but it's all part of the deception. I've spent 30 years of my life believing that we were on a spinning globe. It wasn't until I unbiasedly and scientifically investigated the flat Earth claims that I started to realize that there is more to this theory than I originally gave it credit for. Now, after almost 2 years of research, I'm certain that the Earth is flat. We are told that the Earth spins at 1,040 miles per hour, while the Earth travels around the Sun at 66,000 miles per hour. Meanwhile, the whole solar system is going inside the Milky Way galaxy at a speed of 490,000 miles per hour. And finally, the entire Milky Way galaxy is darting through infinite space at over 1 million miles per hour. Most people believe this, and yet every experiment ever conducted to prove even the simple spin of the Earth has failed. The same thing goes for curvature. It's never been proven, and the only time we see it is in movies, NASA CGI, or when we're looking through a distorted fisheye lens. With all that said, please continue to research critically and don't be afraid to ask reasonable questions and speak out.
Newton theorized, and it is now commonly taught, that the Earth's ocean tides are caused by gravitational lunar attraction. If the Moon is only 2,160 miles in diameter, and the Earth 8,000 miles, however, using their own math and law, it follows that the Earth is 87 times more massive, and therefore the larger object should attract the smaller to it, and not the other way around. If the Earth's greater gravity is what keeps the Moon in orbit, it is impossible for the Moon's lesser gravity to supersede the Earth's gravity at Earth's sea level, where its gravitational attraction would even further out-trump the Moon's. Not to mention, the velocity and path of the Moon are uniform, and should therefore exert a uniform influence on the Earth's tides, when in actuality, the Earth's tides vary greatly. Furthermore, if ocean tides are caused by the Moon's gravitation, how is it that lakes, ponds, and other smaller bodies of standing water remain outside the Moon's grasp, while the gigantic oceans are so affected? Thomas Winship wrote, "If the Moon lifted up the water, it is evident that near the land the water would be drawn away and low instead of high tide caused. Again, the velocity and path of the Moon are uniform, and it follows that if she exerted any influence on the Earth, that influence could only be a uniform influence. But the tides are not uniform. At Port Natal the rise and fall is about 6 feet, while at Beira, about 600 miles up the coast, the rise and fall is 26 feet. This effectually settles the matter that the Moon has no influence on the tides. Tides are caused by the gentle and gradual rise and fall of the Earth on the bosom of the mighty deep. In inland lakes there are no tides, which also proves that the Moon cannot attract either the Earth or water to cause tides. But the fact that the basin of the lake is on the Earth, which rests on the waters of the deep, shows that no tides are possible, as the waters of the lakes together with the Earth rise and fall, and thus the tides at the coast are caused, while there are no tides on waters unconnected with the sea." David Wardlaw Scott wrote, "Even Sir Isaac Newton himself confessed that the explanation of the Moon's action on the tides was the least satisfactory part of his theory of gravitation. This theory asserts that the larger object attracts the smaller, and the mass of the Moon being reckoned as only 1/8 of that of the Earth, it follows that, if by the presumed force of gravitation the Earth revolves round the Sun, much more for the same reason should the Moon do so likewise. Instead of which that willful orb still continues to go round our world. Tides vary greatly in height, owing chiefly to the different configurations of the adjoining lands. At Chepstow it rises to 60 feet, at Portishead to 50, while at Dublin Bay it is but 12, and at Wexford only 5 feet. That the Earth itself has a slight tremulous motion may be seen in the movement of the spirit level, even when fixed as steadily as possible, and that the sea has a fluctuation may be witnessed by the oscillation of an anchored ship in the calmest day of summer. By what means the tides are so regularly affected is at present only conjectured. Possibly it may be by atmospheric pressure on the waters of the great deep, and perhaps even the moon itself, as suggested by the late Dr. Rowbotham, may influence the atmosphere, increasing or diminishing its barometric pressure, and indirectly the rise and fall of Earth in the waters. Dr. Samuel Rowbotham wrote, "It is affirmed that the intensity of attraction increases with proximity and vice versa. How then, when the waters are drawn up by the moon from their bed and away from the Earth's attraction, which at that greater distance from the center is considerably diminished, while that of the moon is proportionally increased, is it possible that all the waters acted on should be prevented leaving the Earth and flying away to the moon? If the moon has power of attraction sufficient to lift the waters of the Earth at all, even a single inch from their deepest receptacles, where the Earth's attraction is much the greater, there is nothing in the theory of attraction of gravitation to prevent her taking to herself all the waters which come within her influence. Let the smaller body once overcome the power of the larger, and the power of the smaller becomes greater than when it first operated, because the matter acted on is now nearer to it. Proximity is greater, and therefore power is greater. How then can the waters of the ocean immediately underneath the moon flow towards the shores and so cause a flood tide? Water flows, it is said, through the law of gravity or attraction of the Earth's center. It is possible, then, for the moon, having once overcome the power of the Earth, to let go her hold upon the waters, through the influence of a power which she has conquered, and which therefore is less than her own? The above and other difficulties which exist in connection with the explanation of the tides afforded by the Newtonian system have led many, including Sir Isaac Newton himself, to admit that such explanation is the least satisfactory portion of the theory of gravitation. Thus we have been carried forward by the sheer force of evidence to the conclusion that the tides of the sea do not arise from the attraction of the moon, but simply from the rising and falling of the floating earth in the waters of the great deep. That calmness which is found to exist at the bottom of the great seas could not be possible if the waters were alternately raised by the moon and pulled down by the earth. Bearing this fact in mind, that there exists a continual pressure of the atmosphere upon the earth, and associating it with the fact that the earth is a vast plain stretched out upon the waters, and it will be seen that it must of necessity slightly fluctuate or slowly rise and fall in the water. As by the action of the atmosphere the earth is slowly depressed, the water moves towards the receding shore and produces the flood tide, and when by the reaction of the resisting oceanic medium the earth gradually ascends and the waters recede, and the ebb tide is produced. This is the general cause of tides. Whatever peculiarities are observable, they may be traced to the reaction of channels, bays, headlands, and other local causes. That the earth has a vibratory or tremulous motion, such as must necessarily belong to a floating and fluctuating structure, is abundantly proved by the experience of astronomers and surveyors. If a delicate spirit level be firmly placed upon a rock or upon the most solid foundation which it is possible to construct, the very curious phenomenon will be observed of constant change in the position of the air bubble. However carefully the level may be adjusted and the instrument protected from the atmosphere, the bubble will maintain its position many seconds together. A somewhat similar influence has been noticed in astronomical observatories, where instruments of the best construction are placed in the most approved positions and cannot always be relied upon without occasional readjustment. If the moon pulled the tides due to its alleged gravity, then why does it only pull the ocean's water and not all the world's lakes, marshes, ponds, and other inland waters? The tides are clearly a product of the interconnected ocean waters, and not the other waters of Earth, and therefore caused either by the gentle rocking of the earth on the great deep, as stated by the above 19th century authors, or, if more ancient explorers can be trusted, the ocean tides very well may be caused by a huge whirlpool vortex surrounding Mount Meru at the North Pole, which reverses direction every 6 hours, alternately sucking in and pushing out the great seas of the earth, like the breath of Gaia at the naval center point of Earth, breathing in and out twice per day. The 14th century writings Inventio Fortunata by Nicholas Stalin and the Itinerarium of Jacobus Snoyen mention the magnetic mountain being so powerful that it pulled the nails right out of explorers' boats. The encircling whirlpool and 4 directional rivers surrounding the mountain were said to change every 6 hours, causing the tides, comparing them to the breath of God at the navel of the earth, inhaling and exhaling the great seas. The cartographer Gerardus Mercator's 16th century map informs us that the waters of the oceans are carried northward to the pole through these rivers with great force, such that no wind could make a ship sail against the current. The waters then disappear into an enormous whirlpool beneath the mountain at the pole, and are absorbed into the bowels of the earth. On Gerardus Mercator's map he wrote, "A monstrous gulf in the sea towards which from all sides the billows of the sea coming from remote parts converge and run together as though brought there by a conduit. Pouring into these mysterious abysses of nature, they are as though devoured thereby, and should it happen that a vessel pass there, it is seized and drawn away with such powerful violence of the waves, that this hungry force immediately swallows it up, never to appear again." Fridtjof Nansen has found mentions of a great northern whirlpool in Norse legends of the world's well, Velgamur, which causes the tides by pushing and pulling waters through its subterranean channels. Isidore of Seville, the Gesta Hemaburgenesis Ecclesiae Pontificum, the Topographia Hibernica of Giraldus Cambrensis. His description of the northern whirlpool is cited by Mercator, the Historia Norvegae, the Speculum Regale of Einar Gunnarsson, and a particularly interesting quote from the Langobard author Paulus Warnefridi, also called Diaconus, states, "And not far from the shore, which we before spoke of on the west, where the ocean extends without bounds, is that very deep abyss of waters which we commonly call the ocean's navel. It is said twice a day to suck the waves into itself, and to spew them out again, as is proved to happen along all these coasts, where the waves rush in and go back again with fearful rapidity. By the whirlpool of which we have spoken, it is asserted that ships are often drawn in with such rapidity that they seem to resemble the flight of arrows through the air, and sometimes they are lost in the gulf with a very frightful destruction. Often, just as they are about to go under, they are brought back again by a sudden shock of the waves, and they are sent out again thence with the same rapidity with which they were drawn in." The Gesta Hemaburgenesis Ecclesiae Pontificum states that Archbishop Adalbert told a team of noblemen of Phrygia around 1035 to 1043 to set sail to explore the North Polar region. As they headed north beyond Greenland, quote, "Of a sudden they fell into that numbing ocean's dark mist which could hardly be penetrated with the eyes, and behold, the current of the fluctuating ocean whirled back to its mysterious fountainhead, and with most furious impetuosity drew the unhappy sailors, who in their despair now thought only of death, on to chaos. This, they say, is the abysmal chasm, that deep in which report has it that all the backflow of the sea, which appears to decrease, is absorbed and in turn re-vomited, as the mounting fluctuation is usually described. As the partners were imploring the mercy of God to receive their souls, the backward thrust of the sea carried away some of their ships, but its forward ejection threw the rest far behind the others. Freed thus by the timely help of God from the instant peril they had had before their eyes, they seconded the flood by rowing with all their might." So in short, what is the cause of the tides? Well, it is clearly not the supposed gravity of the moon, a smaller object than the Earth, far away from the Earth, somehow pulling the tides up in a uniform way, as this doesn't happen. Alternately, it could be, as Samuel Rowbotham proposed, that it is simply the gentle fluctuation of the Earth on the waters of the great deep causing the tides. However, this explanation alone fails to provide an answer for the regularity of tides coming in every 6 hours and going out alternately every 6 hours, to which these ancient explorers offer a possible explanation, and this also, curiously, could be why the flight and sailing restrictions at the North Pole, why people like Rodney Clough were turned away when their vessel tried to explore the North Pole. Russian military vessels and other ships explored the area, making sure that we don't take our own independent explorations to the North Polar region. So what are they hiding there? Does this magnetic Mount Meru actually exist? Is there actually a whirlpool spinning around it with 4 directional rivers constantly sucking in and pushing out the waters of the Earth in 6-hour intervals? It sure would be nice if the UN and world governments would allow us to independently explore the Arctic and Antarctic, so we could find answers to questions like these. When light of any kind shines through a dense medium, it appears larger, or rather gives a greater glare, at a given distance than when it is seen through a lighter medium. This is more remarkable when the medium holds aqueous particles or vapor in solution, as in a damp or foggy atmosphere. You can see this by standing within a few yards of a street lamp and noticing the size of the light. On going away to many times the distance, the light upon the atmosphere will appear considerably larger. This phenomenon may be noticed to a greater or lesser degree at all times, but when the air is moist and vapory, it is more intense. It is evident that at sunrise and at sunset, the sun's light must shine through a greater length of atmospheric air than at midday, besides which the air near the Earth is both more dense and holds more watery particles in solution than the higher strata through which the sun shines at noonday, and hence the light must be dilated or magnified as well as modified in color. So the sun, as it sets towards the horizon, from a viewer's perspective on Earth, simultaneously gets bigger due to the reason given above, and smaller due to the law of perspective. The net result is what you see. Notice how the distant lights have a brighter and bigger glare even though they're further away. Many contributing factors, including wavelength, diffraction, air pressure, air temperature, width of aperture, altitude, humidity, and clarity, all contribute to the net result. The amount to which the sun and moon will be magnified, due to the above reasons, and shrink due to the law of perspective, will depend on all of the above. eNature.com writes, "The moon's warm color when seen at lower angles is caused by the relatively larger amount of atmosphere through which one is observing it as compared to when the moon is right overhead. This additional atmosphere scatters the bluish component of the light of the moon, making the low-lying moon appear redder to the observer's eyes. If you look later when the moon is higher above the horizon, you'll see it appears much whiter than earlier in the evening." It does change, and the changes are mostly due to the atmosphere. So I can show you a picture of the sun setting in the desert where it's very dry, and you'll see the sun shrink and shrink into a tiny, tiny pinprick before it disappears into the horizon. And then I can show you another video of on a more over the ocean, say, on a more humid day, the sun is going to actually expand a little bit due to the atmosphere and then disappear into the horizon like a big ball, as many people have seen it. But either way that it disappears, whether it disappears into a pinprick before leaving the horizon or it expands and goes down the horizon, it's simply moving away from your perspective, as we talked about. It's not actually going down, just like a row of street lamps aren't getting shorter and shorter as they get farther and farther away from you. It's just an element of perspective.
The Earth. Is it really just a big ball floating in space? Spinning on its axis at 1,000 miles per hour? Hurtling around the sun at 67,000 miles per hour? Whizzing through the Milky Way at a milk-curdling speed of over 500,000 miles per hour? And warp driving through the heaven at over 500 million miles per hour? And what about the sun? Is it really 93 million miles away and close to 1 million miles in diameter, with a circumference of nearly 3 million miles? And it's constantly illuminating half of our entire Earth's surface with the rotation of the Earth, creating our 24-hour days, our night and days? Or, shh, the Earth is flat. And maybe it's completely still, just like we experience. And maybe the sun isn't big, but is very small and very close, and not illuminating the Earth from 93 million miles, but is illuminating locally. And maybe everything, the sun, moon, and stars, are not far away, but are circling overhead relatively close. In this video, we're going to explore the latter option, and at the end, we're going to reveal startling evidence through the use of time-lapse photography that the sun cannot possibly be 93 million miles away, but is in fact very close and is illuminating locally as it traverses our flat Earth. Oh man, and watch how this sun comes at you. Boom! I mean, come on. And that's all perspective. If you look at jet trails, Google Images, you'll see them. They start out low at the horizon, they come up overhead. Look at that thing. They come up overhead and then they go down to the horizon. Perfectly explains what the sun would do. Here it is going overhead. I love time lapse. And look at this. You can't go out and look at the sun. You can't see this stuff, except that it's on, time lapse like this. It's incredible. Now watch this thing. It's sweeping. The sun over flat Earth is doing a big circle, right? Look at this thing. See it sweeping to the right? It's like a lefty bowler. Just toss that down the alley, and there it goes, hooking into the pocket. See how the clouds angle down to the horizon. And shot it there. That's exactly how the sun would do on flat Earth. Okay, back to the Copernican principle, and this is what they tell us. The sun is 93 million miles away. Now I'm going to show you evidence through sunsets that shows the sun light following the sun over the horizon, and it shrinks as it goes over. Now there's no way it would do that if the sun is 93 million miles away. Okay, first I'm going to show you some footage from the ISS. Okay, now watch this animation. Watch this sunset. Now this is exactly, if they came to me and said do an animation, this is how I would do it. If the sun were 93 million miles away. Just like that. Have the whole horizon fade evenly. But that's not what we see. Okay, wow, look at that. Look how the light lifts off the ground like a big wedge, or like lifting up a sheet of paper. That's incredible footage. Definitely the light's following the sun, right? Okay, next I'm going to show you how a sun that is circling over the Earth, that creates the horizontal aspect of the sun. If you combine that with perspective, which creates the up and down of the sun, the rising and the setting, you get the 23.5 degree tilt that they talk about. It's nothing but perspective and the circling sun. Here's another sun sweeping out a big circle. Okay, here's a phenomenon that you might be wondering, how in the heck do you explain this on a flat Earth? Well, this footage is taken from Alaska during the summer, and the sun does look like it's going up and down. The reason it's doing that is that this town in Alaska is not in the center of the sun's circular circuit. In other words, the sun is making a big circle, and the town is not in the center of that circle. So the sun will be closer and further from the viewer with the camera. That will cause it to go higher and lower, and also maybe even bigger and smaller. Look at the high altitude airplane. Remember, this is from a high altitude balloon, so that airplane is probably at cruising altitude. Notice how it looks like it's going up from the horizon. That's exactly how the sun will rise, because that plane is staying parallel to the ground. And now watch, it'll go down to the other horizon. All right, again, perspective, that's how the sun will set. And forget the big ball, that's just due to a GoPro camera. But see how the sun, that's the point of this. And then also, look at the size of the sun, man. Look at that thing. I mean, there's something to it to say that we're higher up our view and the sun looks bigger, and it looks like it's not as high in the sky as it does when we're on the ground. Something to that. Let's explore this notion a bit further, that the sun looks bigger when filmed from higher up. The next 3 slides, I'm going to do a comparison, a side by side. The one on the left, the camera is above the clouds. The camera on the right is ground level. And the point for the side by side comparison from the ground level and the level above the clouds is that above the clouds we're only maybe a mile or so up, and if the sun appears to be closer to the camera, well, that means it's probably much closer, because if the sun were 93 million miles away, a mile closer wouldn't make any difference at all to its visual appearance. Okay, here's a little illustrator or a little cartoon from a website called timeanddate.com. It's really funny that they would have a perfect illustration of a sun rising and setting on a flat earth due to perspective. You'll notice that it rises from below the horizon and sets below the horizon. Now you might be saying, well, how's that possible? I can see now you're saying that it rises and lowers due to perspective, but how does it disappear below the horizon? Well, I got a theory about that. Because of the fact that all parallel lines and planes converge at your eye level horizon, this is according to the perspective, I'm not making this up. If in fact, and they do, they converge at your eye level horizon visually, then it makes sense that after that point they diverge, meaning they then separate, so the sun would continue on a downward track. As you can see from my illustration here, the lines would go to your horizon, and then afterwards they would spread out and separate, kind of like a starburst, and the starburst being at your horizon, at your focal point. Anyway, without further ado, we're going to start talking about, and I'm going to start showing you the time lapse of the sunsets that I'm talking about that clearly show the sun is close and illuminating locally. Here we go. All right, and here are a couple of time-lapse sunsets, and just like the sunrises at the beginning of this video where you could see the sun coming at you, not maintaining any 93 million mile distance, here you can also see the sun moving away, and it's clearly not due to the rotation of the Earth and a sun that's maintaining 93 million miles away, but the sun is moving over the Earth and moving away from you. Okay, these next three slides, the sun is almost set already behind the horizon, but watch as the sunlight shrinks and follows the sun. It's definitely a locally illuminating sun, not far away, not very big, and definitely not 93 million miles away. Okay, remember this video from the beginning of the video? I showed you this one and how it's circling over the Earth, and watch it sweep to the right like a bowler bowling it in there for a strike. Okay, now I want you to pay attention to the way the light follows the sun. The sunlight's going to shrink, right, as it follows the locally illuminating sun. Now watch this. See it shrinking, following the sun? You do not get that if the sun is 93 million miles away. The entire horizon should fade evenly, just like this supposed shot taken from space of the Earth. You can clearly see the way they depict it. They depict the demarcation between day and night, or light and dark, as a long straight line. And you can see the long straight line moving as one solid piece. That means that the sunset should all fade, the entire horizon should fade evenly. But that's not what we observe, as we will see and as we've seen in the footage so far. The sunlight shrinks and follows the sun over the horizon. So these time-lapse sunsets are definitely the nail in the coffin for heliocentrism. But this particular one here, shot from above the clouds from this observatory, is the final nail in the coffin. Look at how the sun just shrinks and the light shrinks to nothing. That cannot happen, as I showed you in the when the sun illuminates the entire Earth, which it does from 93 million miles away. It has to. You don't get this isolated look at the sunlight trailing the sun. That's only possible with a small sun, close, not very high, illuminating locally. I mean, if this isn't proof to you, then you gotta take the blinders off. Okay, and finally I want to show you some examples of local illumination, or a city in the background. This is from Grand Canyon National Park. You can see Las Vegas is one of them. You can see the stars going down, so you know that's not the sun. That's the glow of Las Vegas, it says. You can see that's local illumination. I'm just making an example showing you here's Tuba City and a little bit of Flagstaff. Now, in this one here, you see two lights. Obviously, we don't have two suns, but these are two cities lit up, and it's just to show it looks just like the sun going over the horizon. That's the point of me showing that. That's local illumination at work. The sun is not 93 million miles away, because if it was, the entire horizon would fade evenly, and the entire horizon would fade at the same time. Not what we see here, which is the small sun cruising over the Earth and the light is following it. Case closed.
The earth is flat, living in illusion. The earth is flat. We take some illusion. The earth is flat, living in illusion. So people don't know what to do. The earth is flat, living in illusion. The earth is flat, staging illusion. The earth is flat, living in illusion.
Hey everybody, this is a video about the sunbeams or the sun rays that come through the clouds, called crepuscular rays. And what I'm going to do here is prove in this video, with a series of proofs, beyond a shadow of a doubt, that the sun is close and the sun is small. First I'm going to show you an experiment I did with the sun rays. That's very solid proof that the sun is in fact close and not very big. And then I'm going to refute Wikipedia's account of these crepuscular rays. They say that these rays are due to perspective, and that in fact they are, for all intents and purposes, parallel lines from a sun that's almost 1 million miles in diameter. But the fact that we see them splaying out, they say that that's due to perspective. I'm going to show that that's impossible. And then number 3, I'm going to show that it's actually, when you take a look at this picture of the crepuscular rays, that actually perspective is missing from this photo. If in fact the sun were 1 million miles in diameter and 93 million miles away, the heliocentric model is in trouble. So let's get to my experiment. I watched a video from my perspective. His video is called Flat Earth Sunbeams Part 1. I was outside and I go, man, let me try that. I just kind of ran in, I grabbed some cardboard, I cut some holes in it, and I wanted to see how the sun reacts coming through. So here I am, raising it high over my head, so I'm about 8 feet away from this, and the light doesn't diverge or spread out. You know, it doesn't splay out like we see the crepuscular rays. And this sun's far away. Just like in the heliocentric model, the sun is far away, right? 93 million miles away from our clouds. But we see the sun rays splaying out from the clouds as though it were a close sun and not a faraway sun. Well, you can see when it is far away, the light beams are parallel and they don't splay out or diverge from the clouds. So then I got a little bit more sophisticated. I went inside and I cut some nicer holes in another cardboard. You know, my budget went up. And here they are, and I put some CGI here. I put some beams in there, and you can see they are dead straight. No splaying out. And then you can also, there's a part here where I have it up overhead, and I had the same results. No splaying out. So this is the example of the faraway sun. That the rays, this is what we should experience coming through the clouds. The rays from a sun that's almost 1 million miles in diameter and 93 million miles away, when those rays get here, they should be parallel and dead straight. But we don't see them as dead straight. We see them splaying out or diverging from the clouds. Something's not right here. Okay, here I am inside. Notice I got my light close. Look at already, you can see the light splaying out. You see that? I drew you can see the circles on the floor and on my piece of cardboard actually. Those are the original size of the holes that when I was outside they lined up perfectly. Here you can see them completely splaying out. And if I put the rays on it like this, the sun rays, and that's not even as splayed out as they got, it's just that the cloud is in view. And I want you to be able to see the cloud, which is my cardboard with the holes cut out of it. That way I could line up the rays. But as you can see, when I moved up a little bit off the floor and put the light even closer, the rays really splayed out. So I just wanted you to see that. Okay, so there you go. There's hard evidence that when the light source is close to the clouds, the light will diverge. The dispersion pattern you can see when I was outside, the dispersion pattern remained the same, meaning the 5 holes that I had, like that, stayed exactly the same, and that's a faraway light source. But when the light source was close, they splay out. That definitely supports the flat Earth model of a small, close sun. Okay, let's analyze this claim that science makes and Wikipedia makes that the crepuscular rays are due to perspective, that they're actually very close to parallel lines. For all intents and purposes, they are parallel, coming from a sun that's almost 1 million miles in diameter, but we don't see them parallel coming through the clouds. Those crepuscular rays are angled outward. They splay out. They're diverging from the clouds. And Wikipedia is saying that that's due to perspective. Okay, and Wikipedia also uses railroad tracks like these. And they say, see how these converge at your horizon, or they diverge from the perspective of the sun outward? And they're saying that that's what's going on here. Okay, so we need a quick little review of perspective. Notice in this long hallway, all parallel lines and planes angle to the eye level or the eye position of the observer. Notice that the side walls angle in, those are parallel lines to one another, and the ceiling and the floor are also parallel, but notice how they angle toward each other and they come to your eye level. All right, you have an X, Y, and Z axis. So the railroad tracks would fit your Z axis. That's going away from you, and those lines, yes, they converge. But the sun, and especially when the sun's overhead, would be bombarding us with huge vertical parallel lines, or rays, parallel rays. Yet, we don't see any of that, ever. So what I'm going to show you here is that this claim that these crepuscular rays is due to perspective is not true. It's impossible, because perspective will not converge or diverge or splay out lines or planes that are parallel to one another, that are perpendicular to the viewer or his Z-axis. Okay, so like in this picture of the railroad tracks here, the lines going away from you, that's I did with the green line, that's the railroad track, that's obvious. And right from the get-go, they start to converge. Now those are parallel lines, but yet we never see them as parallel. They're always converging as they go away from you. Now the black poles that I have going down the side of the railroad tracks are also parallel lines to one another. but notice that they stay parallel. They don't lose their parallel orientation. They may get shorter and they get smaller, that's true. They do have a sort of a convergence, but they don't change their parallel orientation, these vertical lines, because they're perpendicular to you. Now, this is why invoking perspective to explain the crepuscular rays doesn't work, because perspective does not splay out these vertical lines. Yet, whenever the sun is overhead, we should see vertical parallel rays everywhere, and yet we don't see them. So perspective as an explanation for this is invalid. You know, what we see is the rays emanating from this omnidirectional sun. The rays fit the size of the sun, and the angles of the rays off the sun also fit the size of the sun and the shape of the sun. But they shouldn't fit the size of the sun if the sun is in fact almost 1 million miles in diameter and 93 million miles away. The rays should be huge and the sun small. So that's telling us that the sun is in fact close. Okay, and let's go back to what Wikipedia said. Wikipedia says that the rays from the sun are in fact parallel lines, but we don't see them that way because of perspective. Perspective displays them out. Okay, look at this picture. I put these rays in. Okay, so this is what's really going on, Wikipedia says. They say that rays are really parallel, and they would be from a 1 million mile diameter sun. But this is what our eyes do through perspective. It displays it out. Okay, here's another one. They say this is how they really are. They're vertical and they're parallel, but our eyes splay them out like this. Okay, so then why doesn't perspective take these telephone poles and splay them out like this? We don't see that, do we? Why doesn't it take these buildings and splay them out like this? They're vertical and they're parallel. Well, because what we see, the crepuscular rays, is not due to perspective. It's just due to the nature of an omnidirectional light source with the light coming out in all directions. And it's coming from a small sun. It's impossible that this sun is 1 million miles in diameter, as I've already showed you. So then if it's not perspective, these crepuscular rays are not due to perspective, as Wikipedia and science in general claims they are, then what are they? Well, it's very simple. All they are is radially propagated light. Or another way of saying it, light rays emanating out from a common center, like the sun, or any light. And I understand that the light rays coming off the sun looks like perspective. It shares the common trait where with perspective all the lines and planes converge at a point in the distance called your vanishing point. The sun also has that look where looks like the rays all converge at a point in the center of the light. Actually, the light rays are emanating out from a common center, but I can understand how they look alike, but they're not the same. Okay, that's all it is. And so, as we've already proved, that perspective can't explain the crepuscular rays, because where are all the vertical parallel sun rays then? They don't exist. Okay, so next I'm going to show you with streetlights and sunlight and how they look exactly alike. Okay, let's take a look at some light rays. Let's look at how the sun and a street lamp look the same. The one on the left is a street light and the one on the right is the sun. Okay, notice that the light source and the rays match one another. And with the street light, that light is here on Earth, right? It's right there on your street. And those rays look in proportion to that light. They're also here, right? On your street or wherever you see that light. The sun, they're telling us, is actually far away, but the light rays are close. Like when we see these crepuscular rays coming through the clouds. And did you know that streetlights also have crepuscular rays? Just like the sun does, and you know what? They look identical. Let's have a look. Here on the left, that's a street light, and those are crepuscular rays coming off of that street light, and they look identical. They are in the same proportion as our sun and its rays. And you can't say that that's perspective, because they're right there, and as we've seen, perspective can't explain those rays anyway. So those rays are nothing more than radially propagated light. In other words, it's light coming from a common center. That's all. And look at this one. The left one is a street light. The one on the right are the sun rays. They are both in proportion to one another. The light source matches its rays, which indicates that they're both local. Okay, and this street light is here. We know it's here, and we know those crepuscular rays are here. There's no fooling us and telling us it's 93 million miles away or a million miles in diameter. And it looks just like the sun that they're telling us is far away and huge, and whose light rays are here, though, on the Earth. Same here. Same as what we see in the sky. The sun matches the sun rays. But in the heliocentric model, with a sun that's 93 million miles away and almost a million miles in diameter, the rays should be completely out of proportion, like this. You know, we shouldn't maybe even see the sun. Maybe the sun should just be a blob of light on the other side of our lit up atmosphere from these huge rays. I mean, we see the sun like it's in our atmosphere, like it's close, but it can't be, according to the heliocentric model. And next, I want to show you how, in this photo, perspective is actually missing. And what's ironic is, the very linear perspective that they tried to invoke to explain this photo is actually missing from this photo for the heliocentric model to be true. Okay, so what do I mean by that? Well, I mean, they invoked perspective to describe or explain these crepuscular rays, the fact that they're splaying out from the clouds, because they had to invoke perspective or something, because this picture doesn't work for the heliocentric model. This picture of these crepuscular rays is a problem for their model because the sun is supposed to be a million miles in diameter. But the problem is they've invoked perspective, but perspective doesn't work because, as I've already showed you, it doesn't explain the parallel vertical lines that we should see all over the place. Perspective will not splay those out, right? So these vertical rays should be everywhere, the parallel vertical rays, but we don't see them. The perspective that's missing is like the sun is out there and it's almost a million miles in diameter, right? So its sunbeam, it shoots out a sunbeam, and that sunbeam is 100,000 miles wide, let's say. But what we see from here looks very small, right? But not when it gets here. When it gets here, it's going to be massive, okay? But yet, look at these sun rays coming through the clouds. They're small, they're skinny, they're tiny. They match the local sun that we see in the sky here. So that's what I mean by perspectives missing. And let me give you a couple of real-world examples to help you figure this out. Okay, now imagine you're at a football game, an American football game, and you can see the player, the quarterback, down on the field, and he's as big as a peanut, okay, on the field, even smaller. Okay, and the football is the size of a short grain of rice. And he's got this great arm, and he turns around and he throws that ball up to you in the stands, and he can throw it all the way to you. Now, I got a question for you. When the ball gets to you, is it going to be the size of a grain of rice, or is it going to be the size of a regulation football? Well, it's going to be the size of a regulation football, right? But that's not what we see in this picture with the sun rays. Those sun rays fit the size of the sun. And now let's take a look at this soccer player. All right, for those of you who don't know American football, there, he kicks it, he's far away, and the ball gets to you, it's going to be the size of a soccer ball, right? This is proper perspective. This is the perspective we're not seeing when we look at the sun. The sun that we see in the sky is close. Okay, here's a train leaving a station far away down the tracks. Also analogous to the rays leaving the million-mile diameter sun. Okay, the rays would be massive just like the train is massive compared to that little train station. Right? That's proper perspective. Now look at these shafts of light coming from the sun, the rays. The sun on the right here, each of its rays that you see coming off the sun would be about 100,000 miles wide, just like this. You could fit 10 Earths side by side in that ray. Okay, so when we look at these rays, they're not 100,000 miles wide, and they're diverging out from a small sun that we see in the sky. I mean, that proves right there, the sun is close and small. Now, I know somebody's going to seize upon this and say, hey, wait a minute, but we don't see perspective with the sun traveling over the flat Earth. We should see it shrink to a dot and disappear. We don't see that. Well, I was going to save this for another video, and I maybe still will, but let me introduce to you celestial perspective. It's different than regular perspective that we're used to every day. Regular perspective, we see a train on the tracks, and as it goes away from you, it gets smaller and smaller and smaller until it disappears. But the sun, on the other hand, is different because the sun, when it's quote-unquote next to you, is high overhead and has already experienced a reduction in size. Now, as it goes away from you, it follows the convergence lines down to your horizon, essentially keeping it same distance from you. So the two movements offset each other. The one, the sun moving away from you, and then the visually lowering as it follows the convergence lines down to your eye level horizon. Also, the sun is too big to shrink to a dot anyway, right? It's going to go below the observer's horizon before that happens. Now note this about the convergence lines. Notice that on this wall of lines, the higher up they get, the more steep they get. They orient themselves away from the horizontal and more to the vertical. So the train on the tracks, as that goes away from you, it's right on your eye level. It's actually on your z-axis. Here's a picture of the z-axis, x-axis, and y-axis. It's on your z-axis, so all you can see is the train get smaller and smaller and smaller. You can't see any movement laterally or vertically out of that plane. But the sun is different because the sun, even though it's cruising over the Earth parallel to the ground, it's on a much higher plane. So when it's overhead, it's already had a visual reduction in size. So now when it goes away from you and it follows those convergence lines down, it'll appear to be the same size because the going away and the lowering kind of offset each other. And same as this train. If you put this train high up overhead, that will cause it to already have a visual reduction in size also. So now when it goes away from you, it too will maintain its size. Kind of like if you're flying a kite, right? And you have the kite and it's a mile overhead, well, it'll appear a certain size, right? But let's say it takes a nosedive, but the string stays taut, so it goes all the way to the ground. Now it's a mile further down the road from you, but it's still the same size visually, right? So that's kind of how this works too. So let's recap. In my experiment, I showed that when the sun is close, the rays splay out, but when the sun is far, the rays are straight parallel beams. Yet, this is what they show us, this picture of crepuscular rays, and say that that's a faraway sun. Then I showed you how perspective can't explain what we see because it doesn't splay out things like these poles or these buildings. And then I showed how the sun mimics perspective. It has the same look. The light rays radially propagate outward, or they radiate out from a common center. And that's what we're seeing with the sun. It's not perspective. And then I showed how the streetlights, the crepuscular streetlights, match the sun. The same crepuscular rays from the sun and from the streetlights, and they look identical. Both local light sources and local rays. Then I showed you celestial perspective, and that's different from regular perspective, like the train going down the tracks that's on your same plane as your eyes, and as that goes away, it can only shrink. It gets smaller and smaller. But the sun is high up overhead, so it's vertically already had a visual reduction in size. So as it goes down to your eye level horizon, it'll maintain its same size. Okay, and that wraps up celestial perspective, and that wraps up this presentation. I believe we made a strong case. A lot of evidence here, if not complete proof. And thank you so much for watching. There's only one thing left to do. Let's kick the ball out of here. Take care.
The